The rodent population grew exponentially. In just 8 weeks, the population grew from 60 to 274. If the population continues to grow at the same rate, what will be its size after another 8 weeks have passed? So when something grows exponentially, it means it follows the equation a sub t equals a sub 0 e raised to the kt, where a sub 0 is the initial amount, a sub t is the final amount, k is the relative rate of growth, and t is time. All of these problems you first have to find the k, so you're given enough information in the first sentence, sentence to go ahead and find what k is, because here's your a sub 0, the 60, here's your a sub t, the 274, and here is 8, the a sub t, the time. So we'll go ahead and fill those in. So we have 274 equals 60 times e raised to the k times 8, or 8k. And then we can solve for k. First divide out the 60, so 274 divided by 60 equals e to the 8k. And 274 divided by 60 does reduce. So that reduces to 137 divided by 30. And then we can take the natural log of both sides of the equation. Whenever you solve an exponential equation, you take the natural log of both sides. That allows you to use the power rule for exponents, and the power rule for logarithms rather, so we can move the 8k down and make it a coefficient. So we have natural log of 137 divided by 30 equals 8k times natural log of e, and then the natural log of e is equal to 1. So I just have to divide the 8 out. So I'll write 1/8 times the natural log of 137 divided by 30, and that will equal k. So let's see. You can put that in your calculator if you want and get a decimal approximation, or you can leave it exact. I think I'll put it in my calculator. So 0.1898 is the approximate value for k. And now I can go ahead and use my k along with the initial starting amount in my original problem here. I have a sub t is the amount that I started with, so 60, times e raised to the 0.1898 times t. So I can answer questions now. I can plug in time and calculate final amounts. So we want to know how much there will be after another 8 weeks have passed. So altogether when 16 weeks have passed. So we want the amount in 16 weeks. So that will be 60 e to the 0.1898 times 16. And I have my previous answer in my calculator yet, so I'm not going to be doing any rounding off. I'm going to use previous answer right here in my calculator. Let's see, what do I get? So if you put that in your calculator and round to the nearest integer, you get 1,251 rats. So you notice it didn't just double. You didn't get twice 274 because we're increasing exponentially. Okay, so we don't increase linearly. We increase much more quickly than that.